Hello and welcome. My name is Rajdeep Mukherjee and I am a PhD scholar at the Department of Computer Science and Engineering, IIT Kharagpur. Today I will be presenting our paper titled MTLTS, a multitask framework to obtain trustworthy summaries from crisis-related microblogs. This work was accepted as a full paper at Wisdom 2022. Let me start with a brief overview. Sudden adversities, such as natural or man-made disasters, escalate the speed of news sharing over social media. Large volumes of messages get posted during such emergencies that contain valuable information about various aspects of the unfolding situation. However, manually going through all of them is nearly impossible. Hence, there is a need to summarize the available information effectively so as to aid various concerned stakeholders. But a sizable literature already exists on disaster summarization. The question that arises here is, where do the existing summarizers fail? Let us, for example, consider the unfortunate case of Charlie Hebdo shootings that happened in Paris on 7th of January 2015 and involved the killing of 12 people while 11 others were injured. Let us look at this extractive summary that was generated by one of the recent disaster-specific summarizers from the tweets posted around the event. The sentences seem to provide crucial updates regarding what happened. However, do you observe any issues? The problem is, some of the summary sentences are rumorous or contain unverified information. This affects the reliability of the obtained summaries. But why did this happen in the first place? There are majorly two reasons. First, social media platforms such as Twitter are largely unmoderated. Anyone with a malicious intent can deliberately post wrong information to misguide others. Second, even if well-intended, it becomes difficult to verify the credibility of messages at the time of posting owing to lack of reliable resources. Given such a scenario, merely generating a content-rich summary is no longer sufficient. There is a need to evaluate whether the generated summaries are trustworthy enough to act upon. In this work, we therefore focus on developing a solution for the crucial task of generating trustworthy summaries from disaster-related tweets. Given a stream of tweets posted for an ongoing crisis situation, we expect the model to produce a summary by optimizing the joint score representing the verifiability and summary worthiness of candidate tweets. Looking at existing works, APSL, COUTS, and SCC are three different summarization algorithms that focus on summarizing disaster-related articles or tweets. However, none of them verify the credibility of tweets being included in their summaries. Verisum is the first and only proper baseline for the task. However, it takes a pipeline approach and hence suffers from error propagation between the stages. So, what do we want to achieve? Our primary goal is to design an end-to-end solution for the task of trustworthy summarization. Now, existing disaster-specific summarizers are unsupervised in nature, where the summaries are built by maximizing the presence of event-specific keywords. It, however, affects their ability to generalize across unseen events, presumably with their own set of information classes and associated keywords. We therefore wanted to take a supervised approach as it can implicitly learn the required features. Also, compared to the extensive literature on document summarization, methods focusing on summarizing social media texts are limited. In this work, we additionally wanted to address this gap. So here is what we propose. We model tweet summarization as our main task, while tweet credibility verification plays the role of a very important auxiliary task. We propose MTLTS, a multitask learning-based solution for trustworthy summarization. The model is trained using a hierarchical multitask approach that implicitly mimics a pipeline while addressing its limitations. We train the verifier at a lower layer and use its predictions to train the summarizer at a deeper layer for obtaining the summary worthiness of tweets. Formally, let capital T represent a dataset of tweet threads posted during a crisis event. Each thread Ti consists of a source tweet or claim SI whose credibility needs to be determined. The reply tweets RI star are direct or indirect responses to SI, thereby collectively forming a propagation tree-like structure headed by SI. Our multitask objective is formulated as a supervised classification problem which learns a classifier F from labeled source tweets. For each source tweet SI, the model is expected to generate two scores corresponding to its probability of being verifiable and summary worthy respectively. Here is the architecture of our proposed solution, MTLVS. It consists of two modules, the tweet summarizer and the tweet credibility verifier. We use pre-trained word tweet as our text encoder that is shared by both the modules. For designing our summarizer, we leverage Summarunner, one of the seminal works on extractive document summarization. Since tweets are not well-formed documents, we present a novel way to make the model suitable for summarizing tweets. In the process, we make an attempt to bridge the gap between the two bodies of literature on document summarization and social media summarization as highlighted before. We build our verifier module on top of Cascade LSTM, which is a state-of-the-art rumor classifier. It consists of a bidirectional tree LSTM architecture that is trained to learn rumor-specific signals from the entire information cascade. Referring to the tweet verifier module as shown, each of the green circles represents a tree LSTM node. Solid lines represent the flow of information from the response nodes to the source node, that is in the upward direction. Dashed lines, on the other hand, represent the opposite, that is the information flow in the downward direction. Here, we would like to highlight that the stances of replies to potentially rumorous claims or source tweets also play an important role in determining the authenticity of the claim. For example, a claim which is being denied or questioned in subsequent responses could well be rumorous. While the vanilla Cascade LSTM ignores the stances of response tweets, we design our verifier as a multitask model in itself by combining rumor detection, which happens only at the root of the tree, with stance classification, which happens at all the non-root nodes. This helps us to learn additional rumor-specific signals that will ultimately help in determining the credibility of the source tweet. On the right, we show the way the two modules are connected in a hierarchical fashion in MTLVS. The probability of a tweet being verified or non-rumorous is first generated by the verifier, which is then used by the summarizer, being trained at a deeper layer to calculate the summary worthiness of tweet. The relevance score of each tweet is calculated by combining probability scores generated by the verifier and the summarizer. Here, kappa represents the weightage given to the summary probability scores. Final summary is obtained by solving a constraint maximization problem using ILP, where the objective is to maximize the collective relevance scores of the selected tweets while minimizing redundancy. Moving on to the experiments and results. We perform our experiments on the PHEME dataset consisting of a total of 4,659 Twitter conversation threads posted during 4 breaking news events related to man-made disasters. For each thread, the source tweet is labeled as either rumor or non-rumor by a team of journalists. For each of the 4 events, we obtain the gold standard summaries, one per event, from the authors of Verisum, all of which are around 250 words long. Here are the results for the main task of trustworthy summarization. Verified ratio represents the ratio of summary tweets that are truly verified or non-rumorous as per PHEME annotations. Here I would like to remind the audience that kappa is the weightage given to the summary probability scores. Hence, we postulate that generating summaries with kappa close to 1 would ideally help us in achieving high Rouge1 F1 scores, whereas generating summaries with kappa close to 0 would help in improving the verified ratio of summary tweets. Overall, we observe this phenomenon with MTLTS generated summaries, which confirms our hypothesis. Also, we comprehensively outperform our strongest baselines on both verified ratio as well as Rouge. In the interest of time, I'm skipping the tweet verification and human evaluation results. I would request you to please refer to the paper for more details. Next, we identify 4 classes of information relevant to PHEME events. These are information about victims, police investigation, other event-specific updates, and personal opinions. We then train a weakly supervised classifier to map the tweets to their most suitable class. Distribution of verified and unverified tweets as per PHEME annotations across all the 4 information classes are shown here. We find that around 30% of the tweets contain public opinions on non-situational content, out of which around 87% are verified. This observation led us to investigate if the improved verified ratio scores of MTLTS generated summaries were owing to the inclusion of majorly non-situational tweets. We therefore generate the summaries for all 4 events and show here the percentage distribution of summary tweets across the 4 information classes. We find that averaged over all the summaries, only around 15% of the summary tweets were found to be non-situational, thereby leading us to the conclusion that in addition to capturing trustworthy information, MTLTS generated summaries contain substantial amount of actionable or situational content. Lastly, we wanted to understand whether the veracity of tweets changed over time, and if yes, then what is the relative amount of change across classes. For this, we generate the summaries separately for each class of information. Eventual veracity labels for the source tweets are obtained from a subsequent version of the PHEME dataset. We observe that many tweets originally marked as unverified become eventually verified across all classes. The change is especially noteworthy for the summaries generated from tweets related to police investigations. As official details are gradually released by authoritative agencies, originally unverified tweets change their veracity status, leading to a substantial improvement in verified ratio or EVR scores here for the same set of summaries for the class. To conclude, we present MTLTS, the first end-to-end solution to obtain trustworthy summaries from large volumes of disaster-related tweets. We take a supervised approach which enhances the generalizability of our solution to unseen events when compared to existing methods. We present a novel way to leverage a document summarization technique for summarizing social media posts, here disaster-related tweets. When experimenting on the PHEME dataset, we achieve state-of-the-art results, both for the primary task of trustworthy summarization, as well as the auxiliary task of tweet credibility verification or rumor detection. Deploying our proposed solution to provide trustworthy updates in times of crisis is one of our immediate future endeavors. Here I would like to thank ACM India and the organizing committee of ARCS for giving me the opportunity to present our work. I would also like to thank SERB India for funding my research, and finally Synergy members for their support and motivation. With this, I conclude my presentation. Please do read our paper for more details. I would be more than happy to answer any questions from the audience. Thank you for listening.